Hi guys, welcome back. In this video, we're going to be looking at a numerical example for absolute advantage. Now, before we move on to the video, I would suggest you that you watch my previous video on the theory of absolute advantage in case you haven't, and then come back on this video. Now guys, what I've done here is that I've taken two countries, Sweden and Japan, and same two products, two goods being produced. Let's say that, Sweden can produce two cars and eight toys, while Japan can make eight cars and two toys. Now, guys, here there is a very common mistake or a big mistake that students make is when I'm saying that Sweden can make two cars and eight toys, I'm not saying that it can make two cars and eight toys at one time. I'm not saying that. I'm saying it can make two cars and it can make eight toys. But if Sweden makes two cars and it can make zero toys, and if it uses all the resources to make eight toys, it will make zero cars. Remember that. This is the very big mistake students make. Secondly, Japan can make eight cars, and if it does that, it will make zero toys, while Japan can make two toys with zero cars. So if I plot these values on a production possibility curve, let's draw a simple production possibility curve, and we're going to plot these values on a PPC. So we can see that this is Sweden's PPC, where cars being on the y-axis. So we have two cars and then eight toys, while we have for Japan we have eight cars and we have two toys. So basically we have drawn a PPC and we have plotted these values. Now, as far as the absolute advantage is concerned, we can see that whichever country produces greater number of goods using less resources, that country has an absolute advantage. So Sweden clearly has an absolute advantage in toys because Sweden can produce 8 toys while Japan can only produce 2 toys. Well, on the other hand, Japan has an absolute advantage in cars because it can make 8 cars while Sweden can only make 2 cars, right? So Japan has an absolute advantage in cars while Sweden has an absolute advantage in toys. That's clear. We've also plotted these values on these individual countries' PPFs, right? So drawing a PPF is part of this topic when we're going to be studying comparative advantage as well. So we're going to be plotting over there as well. We're going to be plotting these values on a PPF, right? This is basically telling us a production possibility curve. Production possibility curve, it's simply telling us, Sweden can make 8 toys, and the maximum potential for Sweden is to make 8 toys, and the maximum Sweden can make is 2 cars, while Japan 8 cars maximum and 2 toys maximum. So it's basically telling us both the countries' potential maximum, productive potential, and that's what PPFs usually tell, right? Now, obviously, in order to increase the total output for both these countries, both countries should specialize in the goods in which they have an absolute advantage, and that's what exactly Adam Smith said, right? So let's see what happens after specialization. After specialization, we can see that Sweden has doubled its production of toys, since all resources are used to produce toys now. So when Sweden will double it, because now it has specialized. When you specialize in something, you will double your output. Since now all the resources are diverted towards production of toys, since you double your resources now towards that, all your input factors of production are used for toys. So obviously zero cars are being made, and assuming constant returns to scale, as you double your inputs, your output doubles. So you have now 16 toys for Sweden, while you have 16 cars for Japan, because you're specializing in the production of cars for Japan, and your after specialization, the production for car doubles from 8 to 16 for Japan, right? Now, guys, once countries have specialized and they have doubled their output, they won't consume all of it themselves, right? They will obviously trade it with the other country. But the question arises that at what rate, or at what price, or at what exchange rate will they be traded? Now, here the exchange rate, we're not talking about the exchange rate of currencies, but the exchange rate, that is a rate of exchange for the goods, right? At what exchange rate will they be traded? This means that we need to develop or figure out that exchange rate, or the rate at which one good will be exchanged for the other good. That is, it simply means how many toys, for example, will Sweden export in order to import certain cars, or how many cars will Japan export to import certain number of toys, right? On what terms will the trade take place, right? Now, while calculating the rate at which this trade will take place, or the exchange ratio, we need to ensure that the rate is favorable for Sweden as well as for Japan, so that trade is mutually beneficial for them, right? Only then would both the nations gain from trade. Now, the thing is that in order to calculate a favorable trade ratio, economists say that the trade ratio, remember this and listen to this very carefully, that economists say that the trade ratio, right? The trade ratio should lie between the opportunity cost ratio, which obviously means now that if you're figuring out the trade ratio, and once you've established that the exchange ratio or the trade ratio should lie in between the opportunity cost ratio, so we need to first calculate the opportunity cost ratios now. Right now, how will we do that? How will we calculate the opportunity cost ratio? It's very simple. It's simple math. For example, we know that in Sweden, if Sweden makes, let's suppose, 2 cars, then it has to forgo 8 toys, right? So if it makes 1 car, then how many toys will it have to forgo? You divide 8 by 2, the answer is 4. So in order to calculate 1 car, it has to forgo 4 toys. So the opportunity cost of 1 car is basically 4 toys, right? Now similarly, Japan can make 8 cars, and if it make 8 cars, it forgoes 2 toys, right? So in order to make 1 car, Japan has to forgo how many toys? You divide 8, you divide 2 by 8. So the answer would be 1/4, which is 0.25. So Japan, in order to produce a car, needs to forgo 0.25 toys, right? Now I'm going to be writing these opportunity cost ratios here, and I've written them here. And for Sweden, the opportunity cost ratio is 1 car to 4 toys, which simply means that in order to produce a car, Sweden has to forgo 4 toys, and for Japan, in order to produce a car, it has to forgo 0.25 toys. Now guys, I've made an opportunity cost diagram here as well from the same values that we just calculated. So that you can understand it better. Now this is an opportunity cost diagram. It's simply telling us the opportunity cost ratios. So you could see that, J for Japan here, and you can see that the opportunity cost ratio is 1 car for 0.25 toys. So this line is representing Japan's opportunity cost ratio line, while the blue line, this is representing the Sweden's opportunity cost ratio line, right? Which simply means that for every car that Sweden makes, it forgoes 4 toys. Now you need to understand that this is the opportunity cost ratio diagram, or the line that represents the opportunity cost ratios. Now, in order for you to have a favorable or mutually beneficial gain from trading, that actually this whole process makes sense for both countries mathematically, and both countries mutually gain from trade, what we need to do is that we need to have an opportunity cost ratio that lies in between these two values, that is in between 0.25 and 4. So guys, remember that any exchange rate, or the rate at which the goods are traded, the price at which these goods are traded, the exchange ratio, basically any exchange ratio that lies between these opportunity cost ratio would be favorable for both the countries. So let's say we could take this value as 1, which means that I have calculated an exchange ratio of, let's say, cars to toys. So this is 1 car for 1 toy. So 1 car is exported and 1 toy is imported. 1 toy is exported while 1 car is exported for, simultaneously for both these countries. So this is, you can see that this red line basically lies between these two lines. It lies between the black and the blue line. And these lines are simply representing, the black and the blue line is simply representing the opportunity cost lines, while the red line is representing the trade ratio or the exchange ratio line, right? This is fairly simple stuff. At times, you get these sort of MCQ questions and you're trying to figure out, understand what should be a favorable trade ratio. We're going to be doing such MCQs as well. But first, understand the concept. And if you're understanding this concept by the half of this video, then do mention in the concept that you guys are understanding it and this video is benefiting you. Because obviously, it's a motivation for me as well, okay? Now, moving forward, so I've written these 3 steps. So the first step is that identify which country has an absolute advantage. We have a check on this. We have a tick on this. Number 2, calculate the opportunity cost ratio. We just did that. Calculate a favorable trade ratio, or the exchange ratio, basically. And we have done that as well. An exchange ratio is 1:1, right? So remember that for trade to be mutually beneficial, the exchange ratio should lie between the opportunity cost ratio. So now let's see how would trade be beneficial, as in after trade, what's going to happen. So basically I've put down the values after trade. So what happens is that since the exchange ratio was 1:1, and we know that Sweden was basically, it had an absolute advantage in toys. So it was making 16 toys while Japan was making, Sweden was making 16 toys while Japan was making 16 cars. So, for an exchange ratio of 1:1, so let's say that what happens is that Sweden exports, listen to this very carefully, Sweden exports 6 toys to Japan. So Sweden exports 6 toys to Japan, so we have 6 toys for Japan now, right? Or I could even write this here as well. So we have 6 toys for, if I write this down, we have now 6 toys for Japan. And if we deduct 6 from here, so we have like 10 left for Sweden. Since the exchange ratio was 1:1, so if Sweden's exporting 6 toys to Japan, then Sweden will definitely import 6 cars from Japan as well. So now, or Japan will export 6 cars to Sweden. So now we have like, Sweden is going to import 6 cars from Japan. So we have like 6 cars over here. And Japan is now only left with 10 cars, right? Now, the same values I have actually plotted, and I have actually input these values. Just a second. I have actually input these values over here, and I've written over here as well the same thing, that Sweden has now 6 cars which it actually imported from Japan. These 6 cars came over here, while these 6 toys from Sweden went to Japan over here, right? And now Sweden is left with 10 toys, while Japan is left with 10 cars. But at the same time, Sweden also has 6 cars now, and Japan also has 6 toys. Now, this is quite mutually beneficial, and I'll prove it to you mathematically. How is it beneficial? So I've just, written it just to recap. That what I've written is that if Sweden gives up, and it gives up as in it sacrifices, because when you're exporting something, you're sacrificing domestic consumption, right? Sweden is sacrificing domestic consumption when it is exporting, because it's for international consumers now in Japan. So if Sweden gives up and exports 6 toys to Japan, then Japan will give up and export 6 cars to Sweden, basically, because the ratio is 1:1, right? That is for each car imported by Sweden, okay? Each car imported by Sweden, Sweden exports a toy to Japan, right? And similarly, for each toy that is imported by Japan, Japan exports a car to Sweden based on the exchange ratio 1:1. Now we're going to see how this is mutually beneficial. So 3 things. First, you identify which country has an absolute advantage. That is based on the same cost, which is producing greater quantity. Then you calculate the opportunity cost ratios, and then the opportunity cost ratio, once it is calculated, then the trade ratio should lie in between the opportunity cost ratio. Any value, remember, that lies between any value over here, I've taken a value of 1:1, but any value that lies in between. 1:2 would be favorable as well, 1:3 would be favorable as well, 1:1.5 would be favorable as well, right? I have taken the value 1:1 here because it just makes calculations quite convenient. Now guys, let's see that what is going to happen if a country does not chooses an exchange ratio that is between the opportunity cost ratio. Now what is going to happen and whether trade will be beneficial or not, because this will actually prove to us that why are we taking the exchange ratios in between the opportunity cost ratios. So for example, let's say that in this example we took an exchange ratio of 1:1, right, which was lying, it was lying in between the opportunity cost ratio. We took an exchange ratio of 1 car for 1 toy, right? Now let's say we take an exchange ratio that is not lying in between the opportunity cost ratio. Let's say that we take an exchange ratio of, let's say, 1:5. And now let's see that whether this ratio is going to benefit both the countries, and which will make trade mutually beneficial or not. So now let's say that the trade ratio of cars to toys is for 1 car we have 5 toys, right? Now this ratio is certainly not going to be beneficial. Why? Let's prove it. First of all, let's see that how was the ratio 1:1 beneficial. When we took the exchange ratio 1:1, which was lying in between the opportunity cost ratios, let's see how was this ratio beneficial. Let's prove it mathematically. How was this ratio basically beneficial? So guys, basically initially what we can see is that if you look at the opportunity cost ratios, we can see that if Sweden basically produced and consumed a car himself, or the nation produced the car itself, then it was sacrificing 4 toys, right? If Sweden produced 1 car itself, it sacrificed 4 toys. Now if Sweden is basically because Sweden is basically specializing in toys, right? So now if Sweden imports 1 car, then it only needs to sacrifice 1 toy. While before, in order to produce 1 car, Sweden had to sacrifice 4 toys. But now, since Sweden is specializing in toys, so it is going to import 1 car from Japan. And if it imports 1 car from Japan, then it only needs to give up 1 toy. While before, in order to consume 1 car, it had to produce 1 car and then give up 4 toys. So now it can. So now what's happening is that now Sweden can actually consume 1 car by importing, and it only needs to sacrifice 1 toy. That is, give away 1 toy by exporting it to Japan. While previously it had to, in order to make a car itself, it would have to give up 4 toys. So definitely this exchange ratio is beneficial for Sweden, right? Now let's see how would the exchange ratio 1:5 not be beneficial for let's say Sweden. What's going to happen if trade takes place at this ratio? So now what's going to happen is that, let's say that ratio is not between the opportunity cost ratio and the ratio is 1 is to 5. Then in this case, we will see that Sweden is importing one car, right? But it is now exporting 5 toys. It's sacrificing 5 toys. And Sweden was better off not trading with Japan in this case, because it could have made the car himself. It could have made the car itself by sacrificing 4 toys. I mean, what's the point of importing one car and sacrificing 5 toys and exporting 5 toys and reducing the output, reducing the consumption by 5 toys, when Sweden could itself have made one car and sacrificed 4 toys? So definitely this doesn't make sense. It's not mathematically beneficial for Sweden anymore. This sort of ratio Sweden is not benefiting from, because Sweden could have made the car itself and sacrificed 4 toys, while now instead of just making the car itself, it's importing one car, but then it's sacrificing 5 toys now. So Sweden is worse off in this case, right? While if we see the opportunity cost ratios for Japan, we have one car for 0.25 toys, right? One car for 0.25 toys. Now guys, the exchange ratio 1 is to 1, that is one car for one toy, is also beneficial for Japan as well. And we can see why is it beneficial for Japan. Because Japan basically initially could produce, if Japan produced 0.25 toys, it had to give up one car, right? I'm saying it again, if Japan had to produce 0.25 toys, it had to give up one car. But now Japan can actually import one whole toy by giving up one car. Since Japan is basically specializing in cars, so it's exporting one car, right? I'm going to say it again. Since Japan is specializing in cars, it is exporting one car, and at the same time it is importing one toy. While previously it's importing one toy, which means it's consuming one toy. And it's exporting one car, which means it's sacrificing one car, right? But previously, Japan, if it produced 0.25 toys, that is not even half a toy, 1/4 of a toy. Japan could only basically produce 0.25 toys. Previously, Japan could only produce 0.25 toys. At the same time, it had to sacrifice one whole car for only 0.25 of a toy. But now Japan is better off, because initially it was consuming 0.25 of a toy by sacrificing one car, 0.25 of a toy by sacrificing one car. But now Japan is actually consuming one entire toy by sacrificing the same one car. So isn't Japan better off? Isn't Japan better off in the sense that now still it is sacrificing the same one car as it was before, but this time it is exporting it. Previously, it was not producing it. It was sacrificing by not producing that car, and now it is sacrificing by exporting that car. But see what Japan is getting in return. Japan is getting one entire toy in return. Previously, it was only producing this toy, but it was only producing 0.25 of a toy, not even half a toy. 0.25 of a toy, again sacrificing one entire car. But now it can sort of consume one toy by importing it, by sacrificing the same one car. So isn't Japan better off? Isn't this ratio also good for Japan? So you see, that's why this exchange ratio, since it lies between the opportunity cost ratios, between both the countries' opportunity cost ratio, right? The thing is that this exchange ratio of 1 is to 1 is lying in between both the countries' opportunity cost ratios. And since it is lying in between both the countries' opportunity cost ratios, it is going to mutually benefit both the countries, Japan and Sweden as well. But a ratio of 1 is to 5, this ratio of 1 is to 5 is not lying in between the opportunity cost ratio. Hence, this will only benefit one country. First of all, it is not benefiting Sweden at all. We know that, right? We've seen it's not benefiting Sweden. But an exchange ratio of 1 is to 5 will although benefit Japan, but this will not benefit Sweden. How will it benefit Japan? It will benefit Japan because Japan initially, by producing 0.25 toys, it had to sacrifice one whole car. But let's say with the ratio of 1 is to 5, Japan can actually import with the ratio of 1 is to 5, Japan can actually import 5 toys, still sacrificing only one car. So Japan is getting more toys basically in this way by sacrificing the same car, while before it could only produce 0.25 toys by sacrificing one car. So Japan is, with a ratio of 1 is to 5, it will benefit Japan, but it will not benefit Sweden. And so if that's the case, then why will Sweden enter into a trade with Japan for an exchange ratio that does not benefit Sweden, and only benefits Japan. So for trade, we need to understand that in order for the theory of absolute advantage to work and for this theory to be beneficial for both the countries, right? Not just one country, for both the countries, because countries will enter into trade when it is beneficial for both the countries. There is something of value for Sweden and for Japan. It makes Sweden better off and Japan better off as well. The exchange ratios should lie in between the opportunity cost ratio. So this ratio will definitely not work, and what we conclude is that the ratio should lie in between the opportunity cost ratio, as we have already established, right? So 1:1 is favorable for Sweden and it is favorable for Japan as well. Okay guys, now what we have here right now is that we are going to prove mathematically with numbers, actual numbers, that how the after trade position, after specialization in trade, how is that better for both the countries, for both these nations, as compared to the pre-trade position. Now we know that before trade, these two countries, Sweden and Japan, if you look at these values, so Sweden could actually make 2 cars, but if it made 2 cars, it had to forgo 8 toys. If it made 8 toys, it had to forgo those 2 cars. While Japan, on the other hand, had to sort of forgo 2 toys for 8 cars, and uh, you know, for 2 toys, it had to forgo 8 cars, and for 8 cars, it had to forgo 2 toys, right? If we look at Japan, but now after trade, these are the same values that I've copied from here, right? These are the same values, and if you look at these values, if you look at the after trade position, and you compare it before trade, now Sweden can actually consume 10 toys before it could produce and consume 8 toys, but now it can consume 10 toys, right? Which means that it can consume 2 more toys. Sweden can now consume 2 more toys, right? And previously, if it produced and consumed 8 toys, it could produce 0 cars. With 8 toys, it could produce 0 cars. But now, with consuming 10 toys, it can also consume 10 cars. So Sweden is definitely better off than before. Previously, it could only produce and consume 8 toys with 0 cars. Now it can actually consume 10 toys at the same time consuming 6 cars as well. And if you look at Japan, Japan on the other hand could produce a maximum of 8 cars with 0 toys, but now Japan can consume 10 cars instead, right? And it could actually consume 2 more cars. Japan could consume 2 more cars. At the same time, with consuming 10 cars, Japan can also consume 6 toys. This is and, guys, remember this. So these values are or 2 cars or 8 toys, 8 cars or 2 toys. But now we have and over here, 6 cars and 10 toys. 10 cars, Japan can produce Japan can consume 10 cars and 6 toys. So don't you think that the consumption possibility has exceeded the production possibility before? So what we see over here is that the consumption possibility has exceeded the production possibility. The production possibilities before were a maximum of 8 toys with 0 cars. But now Sweden can actually consume 10 toys with 6 cars. So it's the same thing I've written, that Sweden can now consume 6 cars and 10 toys, while Japan can consume 10 cars and 6 toys. So the consumption possibility exceeds the production possibility, right? If you look at these diagrams, basically, if you look at this PPF, basically, this is showing Japan's PPF, where Japan could make 8 cars and 2 toys, and Sweden could sort of 8 cars, as in the maximum 8 cars with 0 toys and 2 toys with zero cars, and Japan's PPF, which was a maximum of 2 cars with 0 toys and a maximum of 8 toys with 0 cars. But now these were the production possibility curves. These were the PPCs. But guys, this red dotted line is representing the consumption possibility curve. We can clearly see that, guys, the consumption possibility curve has exceeded the production possibility curve. For both the countries, the consumption possibility is more than the production possibility. Sweden can consume beyond its PPF. Japan can consume beyond its PPF. And we can see that. Look at the values for Sweden. 6 cars and 10 toys. So for Sweden, 6 cars and 10 toys would be somewhere around 6 cars and 10 toys would be somewhere around here, right? And let's say, this is not a graph, so I'm just drawing it. It's not drawn to scale. So like 6 cars and 10 toys would be somewhere around here, let's say. 10 toys, 6 cars. While for Japan, it's 10 cars and 6 toys. So for Japan, it would be, let's say, 10 cars and 6 toys. So you can see that how the consumption possibility has exceeded, guys, the production possibility. Both these nations are actually consuming beyond what they were initially producing, right? And this is actually good for both the countries. It's good for the world as well. It's good for the welfare of the consumers as well. So both nations has gained as well, right? So Sweden and Japan, and the world output has gone up as well. So Sweden and Japan can actually, after specialization, and trade, they can consume beyond the production possibilities before trade. So this was a very important video. Now in the coming videos, we're going to be discussing the comparative advantage, and I'm pretty sure now you have understood the concepts behind these exchange ratios and why do we need to calculate the exchange ratio between the opportunity cost ratios. So I hope to see you all around in the next video. Until then, take care.